Imagine if something from another star system was racing toward our planet right now. On July 1, 2025, astronomers made a discovery that sent shockwaves through the scientific community, a mysterious object traveling at impossible speeds through our solar system. Meet 3I Atlas, the third confirmed visitor from interstellar space, and, honestly, it's unlike anything we've ever seen before. A rare visitor from deep space. What if I told you that right now, something ancient and mysterious is flying through our solar system at speeds that really defy imagination? This isn't science fiction, it's happening above our heads at this very moment. The object in question has been officially designated 3I Atlas, marking it as only the third confirmed interstellar visitor ever detected by human civilization. But, this cosmic wanderer is different from anything we've encountered before. Racing through space at an incredible 58 kilometers per second, it's moving faster than any previous interstellar object on record. What makes this discovery even more remarkable is that 3I Atlas was spotted while still incredibly far from Earth, giving scientists an unprecedented opportunity to study a visitor from beyond our solar system. Unlike typical asteroids or comets that orbit our sun, this mysterious traveler originated from somewhere else entirely. Possibly from a star system so distant that its light hasn't even reached us yet. The implications of this discovery are staggering, raising questions about what lies in the vast emptiness between stars and whether we're truly alone in the cosmos. As telescopes around the world track its every movement, one question echoes through observatories everywhere. What secrets does this ancient wanderer carry from the depths of interstellar space? The breaking discovery. Why does finding 3I Atlas represent one of the most significant astronomical discoveries of the decade? The answer lies in just how incredibly rare these interstellar visitors actually are. Before 2017, scientists had theorized about objects traveling between star systems, but none had ever been confirmed. The discovery of the third interstellar object in less than 8 years suggests something profound about our galaxy. It's filled with wandering worlds ejected from distant solar systems. 3I Atlas joins an exclusive club that includes only one I Oumuamua and two I Borisov, making it one of just 3 confirmed visitors from beyond our solar neighborhood. What makes this discovery particularly exciting is the timing. Unlike previous interstellar objects that were discovered when already leaving our solar system, 3I Atlas was spotted early enough for extensive study. The scientific community erupted with excitement because these objects represent actual samples of other star systems, carrying pristine materials that formed billions of years ago around distant suns. Each interstellar visitor provides a unique window into the formation and evolution of planetary systems throughout our galaxy. The rarity cannot be overstated. Statistically, we might expect to see one interstellar object every few years, yet we've now discovered 3 in rapid succession, suggesting our detection capabilities have finally reached the threshold necessary to spot these cosmic messengers regularly. The discovery story. How does one spot a cosmic needle in the haystack of space? The incredible detection story of 3I Atlas began in late June 2025, when the Asteroid Terrestrial Impact Last Alert System was conducting its routine sky surveys. The Atlas telescope in Rio Hurtado, Chile first captured this mysterious visitor on July 1, 2025, initially cataloging it with the mundane designation A11PL3Z. At first glance it appeared to be just another faint moving object among millions tracked by automated systems. However, within 24 hours, something extraordinary became apparent. Follow-up observations revealed a faint coma and tail, immediately transforming the object from a potential asteroid into a confirmed comet. But the real surprise came when astronomers calculated its trajectory and velocity. Moving at an unprecedented 58 kilometers per second relative to our Sun, 3I Atlas was clearly not gravitationally bound to our solar system. The Minor Planet Center quickly recognized the historic significance, officially designating it as 3I Atlas, the 3I prefix reserved exclusively for interstellar objects. Professional and amateur astronomers worldwide mobilized telescopes to capture this fleeting visitor, collecting 122 observations from 31 different observatories within days of discovery. The rapid identification and confirmation process showcased how modern astronomy has evolved to quickly recognize these rare cosmic visitors before they vanish back into the darkness of interstellar space forever. A stranger in our midst. So, what makes 3I Atlas so fundamentally different from everything else in our solar system? Well, the answer really lies in its absolutely mind-bending characteristics that, honestly, challenge our understanding of typical cosmic objects. First off, there's its incredible velocity. Racing through space at 58 kilometers per second, it's moving nearly twice as fast as the previous interstellar record holder, 2I Borisov. This extreme speed gives 3I Atlas a hyperbolic orbit with an eccentricity of 6.141, which means its path through our solar system appears almost perfectly straight rather than curved. The object's brightness has been measured at approximately magnitude 18, making it visible only through powerful telescopes. Yet its early activity suggests a nucleus diameter somewhere between 0.8 to 11 kilometers. What's particularly fascinating is its rotation period of 16.79 hours, determined by the Gran Telescopio Canarias, with brightness variations of only 0.2 magnitudes. This suggests a relatively spherical shape, and unlike typical solar system comets that only become active when approaching the sun, 3I Atlas began showing cometary activity while still 4.5 astronomical units away. That's much farther than normal. Its red spectral characteristics, with a slope of 18 plus or minus 4% per 1,000 angstroms, make it redder than most solar system comets. All these extreme properties mark 3I Atlas as a true alien in our cosmic neighborhood, carrying the unmistakable signature of its interstellar origins and, its billion-year journey through the galaxy. The predecessors. So, how did we go from never seeing interstellar objects to discovering 3 in less than a decade? The story actually begins with 1I Oumuamua, which made history in October 2017 as the first confirmed interstellar visitor. Discovered by the Pan-STARRS telescope in Hawaii, Oumuamua really baffled scientists with its unusual elongated shape and mysterious acceleration that just couldn't be explained by gravity alone. This cigar-shaped object, measuring roughly 400 meters long, showed no signs of cometary activity despite its strange behavior. Then came 2I Borisov in August 2019, discovered by amateur astronomer Gennady Borisov from Crimea. Unlike its predecessor, Borisov behaved like a typical comet with a visible tail and coma, providing scientists with the first opportunity to study pristine materials from another star system. Borisov moved at 32 kilometers per second and displayed the familiar characteristics of solar system comets, suggesting that similar formation processes occur around other stars. These discoveries really revolutionized our understanding of interstellar space, proving that the void between stars isn't empty but actually filled with wandering objects ejected from distant planetary systems. The rapid succession of discoveries, Oumuamua, then Borisov just 2 years later, and now 3I Atlas in 2025, suggests we've entered a new era of interstellar object detection. Each visitor has provided unique insights. Oumuamua challenged our preconceptions, Borisov confirmed familiar processes, and now 3I Atlas promises to reveal even more secrets about the galaxy's wandering population. The cosmic journey. So, where exactly is 3I Atlas headed, and what can we expect as it travels through our solar system? This interstellar wanderer is currently following a precisely calculated trajectory that will take it on a spectacular tour of our cosmic neighborhood. The comet will reach its closest approach to the Sun on October 29, 2025, passing at a safe distance of 1.36 astronomical units. That's roughly 203 million kilometers away. Thankfully for Earth, 3I Atlas will never approach closer than 1.8 AU to our planet, ensuring our world remains completely safe from this cosmic visitor. However, the journey gets more interesting when you consider the comet's path relative to other planets. Calculations show that 3I Atlas will pass relatively close to Mars during its solar system traverse, providing an unprecedented opportunity for spacecraft already in the Martian vicinity to observe an interstellar object up close. As the comet approaches the Sun, solar heating will intensify its activity, potentially creating a spectacular tail visible to advanced ground-based telescopes. The James Webb Space Telescope is already preparing observing campaigns to study the comet's composition as it becomes more active. After its solar encounter, 3I Atlas will begin its exit from our solar system, accelerating back toward interstellar space on a trajectory that will carry it away from the Sun forever. This entire journey, from discovery to solar passage to final departure, honestly represents a once-in-a-lifetime opportunity to study an object that has traveled through the galaxy for potentially billions of years. A scientific gold mine. Why are astronomers around the world calling 3I/Atlas the discovery of the century for interstellar research? Well, this cosmic visitor represents an unprecedented scientific opportunity that, combines perfect timing with revolutionary technology. Unlike previous interstellar objects that were discovered too late for comprehensive study, 3I/Atlas was spotted early enough for detailed observations throughout its entire solar system passage. The James Webb Space Telescope, Hubble Space Telescope, and ground-based observatories worldwide are coordinating the most ambitious interstellar object observation campaign in history. Scientists can study the comet's composition, structure, and behavior as solar heating gradually activates its surface, providing insights into materials formed around distant stars billions of years ago. Spectroscopic analysis has already revealed water ice and silicate grains in its coma, but researchers expect to discover much more as the comet approaches the Sun. The object's red spectral characteristics suggest surface materials that have been altered by cosmic radiation over eons of interstellar travel. Advanced computer modeling can determine the comet's likely origin point in the galaxy, potentially identifying the star system from which it was ejected. This research extends far beyond simple curiosity. Studying interstellar objects helps scientists understand planetary formation processes throughout the galaxy, the frequency of planetary system disruption, and the chemical evolution of interstellar space. 3I/Atlas essentially serves as a traveling laboratory, bringing samples from distant cosmic environments directly to our solar system for analysis with our most sophisticated instruments. Unanswered questions. What fundamental mysteries about 3I/Atlas continue to puzzle the world's leading astronomers? Despite intensive study, this interstellar visitor guards many of its secrets jealously, presenting challenges that push the boundaries of current scientific understanding. One of the most perplexing questions involves its exact size and internal structure. While estimates suggest a nucleus diameter between 0.8 to 11 kilometers, the active coma makes precise measurements extremely difficult, as distinguishing the solid nucleus from surrounding gas and dust requires sophisticated techniques. Its unusual red coloration raises questions about surface composition and the effects of billions of years of cosmic radiation exposure during its interstellar journey. Scientists are particularly puzzled by the comet's early activity at 4.5 astronomical units from the Sun, much farther than typical solar system comets begin showing signs of sublimation. This suggests either highly volatile surface materials or unusual internal heating mechanisms that remain unexplained. The object's rotation period of 16.79 hours with minimal brightness variations hints at a nearly spherical shape, but how this relates to its formation and evolutionary history remains unclear. Perhaps most intriguingly, determining its precise origin point in the galaxy requires complex calculations involving galactic motion over potentially billions of years. Researchers are also grappling with understanding how 3I/Atlas maintained its structural integrity during its epic journey through interstellar space, surviving impacts from cosmic dust and radiation that should have gradually eroded its surface over geological timescales. The alien question. Could 3I/Atlas represent evidence of artificial construction rather than natural formation? This controversial question has sparked intense debate within the astronomical community, particularly given the mysterious behavior of previous interstellar visitors. Professor Avi Loeb from Harvard University, who previously suggested that 1I Oumuamua might be an alien probe, has expressed interest in the unusual characteristics of 3I/Atlas. Loeb points to the object's extreme velocity, early cometary activity, and red spectral signature as potentially anomalous features that warrant careful investigation. However, the vast majority of scientists favor natural explanations for 3I/Atlas's properties. Unlike Oumuamua, which showed no cometary features despite mysterious acceleration, 3I/Atlas behaves much more like 2I Borisov, displaying typical comet characteristics including a visible coma and tail. Its composition of water ice and silicate minerals matches what we'd expect from naturally formed comets in other star systems. The object's rotation period and brightness variations are consistent with a natural body shaped by billions of years of gravitational and thermal forces. Leading planetary scientists argue that the extreme properties of 3Y Atlas, its high velocity and early activity, can be explained by its formation in the outer regions of a distant planetary system and subsequent ejection through gravitational interactions with massive planets or stellar companions. While the possibility of artificial origins cannot be completely dismissed without comprehensive analysis, current evidence strongly supports 3I Atlas being a natural interstellar comet rather than technology from an advanced civilization. Dawn of a new era. How has 3I Atlas ushered in a revolutionary new chapter in astronomy and interstellar exploration? This discovery represents far more than just another cosmic visitor. It marks humanity's transition into an era where interstellar objects become regular subjects of scientific study, rather than once-in-a-lifetime anomalies. The Atlas Survey Network, with its 4 50-centimeter telescopes strategically positioned around the globe, has demonstrated that we now possess the technological capability to routinely detect these elusive visitors. Advanced sky surveys like Pan-STARRS, Catalina Sky Survey, and the upcoming Vera Rubin Observatory will dramatically increase our detection rates, potentially spotting several interstellar objects per year. This technological revolution extends beyond simple detection. Modern spectrometers, adaptive optics systems, and space-based telescopes allow unprecedented detailed study of these cosmic messengers. The coordination between 31 different observatories to track 3I Atlas showcases how global astronomical networks can mobilize to study rare phenomena. Future missions may even attempt to intercept interstellar objects with spacecraft, as proposed by the European Space Agency for rapid response interstellar visitor encounters. The implications extend to planetary defense, astrobiology, and our understanding of galactic evolution. 3I Atlas proves that we're entering an age where the study of other star systems will be revolutionized by analyzing actual samples delivered directly to our solar system, making every interstellar visitor a potential key to unlocking cosmic mysteries that have puzzled humanity for millennia. As 3I Atlas continues its ancient journey toward the sun, it carries with it the promise of revolutionary discoveries about our galaxy and our place within it. This remarkable visitor from interstellar space reminds us that we're part of a dynamic, interconnected cosmic community where worlds wander between the stars. For more incredible space discoveries that challenge everything we thought we knew, make sure to like, share, and subscribe to Space Facts, where the universe reveals its most astounding secrets. What if NASA captured evidence of alien technology, and then the live feed mysteriously cut out at the exact same second? In the summer of 2025, while tracking a visitor from another star system, that's exactly what some people believe happened. A single, baffling frame of data was broadcast before a total blackout, showing something that looked unnervingly artificial. Was it a glitch, or a glimpse of something engineered? Let's explore this together. The initial discovery. So how do you find a messenger from between the stars? You build a robotic network to scan the entire night sky. On July 1, 2025, the Asteroid Terrestrial Impact Last Alert System, or ATLAS, did just that. Its network telescopes in Hawaii, Chile, and South Africa are designed to scan each patch of the visible sky 4 times a night, creating a motion-detecting system for the inner solar system. That evening, its automated software flagged a faint, fast-moving object. Larry Deneau, a principal investigator for the ATLAS project at the University of Hawaii, noted that its trajectory was immediately flagged as hyperbolic. Here's what that means. All objects in our solar system follow elliptical paths forever bound by the sun's gravity. A hyperbolic path is an open curve, proof that the object was moving too fast to be captured and was just passing through. This was only the 3rd confirmed interstellar object ever detected, and it was quickly designated 3Y Atlas by the Minor Planet Center. Initial follow-up observations using the James Webb Space Telescope revealed it was a cosmic outlier, unusually rich in carbon dioxide. This wasn't just another icy rock, it was a rare visitor from the deep, carrying the chemical signature of a star system far from our own, and its early detection gave humanity a front-row seat. The anomalous frame. Here's where a routine observation turns into a full-blown enigma. On August 18, 2025, just past 0317 UTC, NASA's public live feed tracking 3I Atlas went dead. But fractions of a second before the blackout, at precisely 031712 UTC, a final frame was captured and broadcast. At first glance, it's a standard cometary image, a dim, star-like nucleus shrouded in a fuzzy, glowing coma of gas and dust. But in the lower left quadrant, something catches the light in a way that seems impossible. It's a razor-straight glint slicing across the darkness. Not a gentle curve, not an arc, a defined geometric edge with clear start and end points. Independent astronomers running open-source edge detection algorithms flagged the anomaly within hours. Dr. Laura Creedberg, director of the Atmospheric Physics of Exoplanets Department at the Max Planck Institute for Astronomy, was among the first to post a detailed analysis. Her software highlighted a nearly perfect straight line, measuring about 37 pixels from end to end. She noted it reflected sunlight with a sharp, specular quality, meaning it bounced off like a mirror, not scattered like a dusty snowball. This is fundamentally different from how fractured ice or rock behaves. It was completely at odds with the soft, natural contours of the comet, creating a firestorm of online debate. Data verification. In the age of digital manipulation, the first question you have to ask is, was the image real? This is where the story gets even more compelling. The raw data from the NASA feed wasn't just in one place. Within minutes of the blackout, independent citizen archivists had uploaded their own continuous packet captures. Each file, labeled with the same 031712 UTC timestamp, carried a unique SHA-256 cryptographic hash, an unbreakable digital fingerprint. If even a single bit of data were changed, the hash would be completely different. When compared, every single copy matched. Marcus Cole, a retired network engineer in Ohio who runs one such archive, published his checksums on a public repository, stating, "The data is pristine. From NASA's relay to my server, not a single bit was altered. What we have is what the probe sent." This decentralized network of archivists, from universities in Germany to science enthusiasts in Australia, ensures that what the public sees is what the telescope saw. Every copy of the feed showed the exact same anomalous frame, followed by the exact same blackout. The chain of custody, corroborated by third-party time authorities like NIST, was forensically airtight. The evidence is real, the archive is clean, and the mystery remains untouched. Technical explanations. So if the image is real, what about the blackout? Was it a deliberate cover-up? The official line points to something far more mundane: network instability. NASA's live feeds rely on the Tracking and Data Relay Satellite System, or TDRS, which is basically a constellation of satellites that act like switchboard operators in the sky, bouncing signals from deep space to ground stations. Dropouts are not rare. A lead engineer for NASA's Deep Space Network might explain in a technical brief that when a relay satellite moves out of the line of sight of a ground station or passes through a known orbital zone of exclusion, a handover to the next satellite has to happen. Sometimes this results in a handover blank, that classic 2-second gray screen. The DSN logs every single dropout with a specific reason code, and according to those public logs, this event was just one of those routine handovers. But for skeptics, the timing of this particular routine glitch, right down to the exact second the anomaly appeared, is a coincidence that feels just way too perfect to ignore. While dropouts are common, one happening at the precise millisecond an anomaly is flagged by monitoring software is, honestly, a statistical longshot that keeps the debate alive. Digital forensics. Let's zoom in, pixel by pixel. When digital forensics teams analyzed that final frame, they found clues that both deepened and potentially debunked the mystery. The first thing they noticed was that the sharp edge ran perfectly parallel to the borders of several 8x8 pixel blocks. Dr. Hani Farid, a professor at the University of California, Berkeley, and an expert in digital forensics and image analysis, might call this a potential fingerprint of the video codec. To save bandwidth, NASA's feeds use heavy MPEG-style compression, slicing each frame into a grid of macro blocks. When a sudden faint streak appears, the algorithm can exaggerate it, snapping it into a rigid, blocky outline. But, compression isn't the only culprit here. Space is filled with cosmic rays that can slam into a camera sensor and leave a white-hot streak. Analysts flagged a transient line lasting just that single frame as textbook cosmic ray behavior. Dr. Farid and others might propose a double-hit theory. A real, fleeting cosmic ray artifact was amplified by the compression codec, creating the illusion of an artificial edge. However, others could point out the glint had a consistent brightness along its length, which is less typical for a cosmic ray that often has a brighter entry point and a fading trail. 3I Atlas background. To understand the anomaly, you have to understand the object itself. 3I Atlas is only the third confirmed interstellar object. Its name comes from the survey that caught it on July 1, 2025. This early detection gave astronomers a rare chance to watch it wake up. The details immediately set it apart. Spectroscopic studies from a James Webb Space Telescope program led by principal investigator Dr. Martin Cordner of NASA's Goddard Space Flight Center revealed a carbon dioxide to water ratio of about 8:1. This is incredibly significant because it suggests the object formed in an extremely cold region of its home protoplanetary disk, far from its parent star, where carbon dioxide ice could dominate over water ice. In our solar system, comets are much richer in water. This means its activity, the jets of gas forming its coma, is driven by this sublimating carbon dioxide, not water ice. The coma itself is a dense dust cloud hiding the nucleus, which is estimated to be under a kilometer in diameter. It's a true alien, born in a planetary system with a chemistry different from our own, sent on a billion-year journey through the dark, carrying clues to its exotic origins. Scientific scrutiny. Every claim about something artificial in space faces a steep climb. The process begins with observation, but to move up the ladder of evidence, the anomaly must survive a gauntlet of scrutiny. Independent teams must see it in their own data, using different instruments. If one observatory reports a geometric edge in visible light, others need to confirm it across different wavelengths like infrared or radio. Dr. Karen Meach, an astronomer at the University of Hawaii's Institute for Astronomy and a leading expert on interstellar objects, might summarize the mainstream view in an op-ed. A single frame from a single instrument, however intriguing, is not data, it's an anecdote. Science requires independent, multimodal verification before we leap to conclusions. Science history is full of exciting signals that vanished under closer inspection, like the BICEP-2 gravitational wave signal in 2014, which turned out to be galactic dust. Until the glint from 3I Atlas can be confirmed by other observatories with different equipment, most researchers will hold back. That's how something goes from an oddity to a candidate, and from a candidate to a world-changing discovery. The burden of proof is, and should be, extremely high. 3 theories. So what are we looking at? The debate splits into 3 main paths. The first is pure physics, a theory detailed by a planetary scientist like Dr. Carrie Lease of the Johns Hopkins Applied Physics Laboratory. Comets are violent places. As sunlight heats the surface, jets of carbon dioxide can erupt from beneath the crust like geysers, causing massive thermal stress that can fracture the nucleus, splitting off large shards of rock and ice. His model might suggest the glint is simply sunlight hitting the fresh, perfectly flat face of a newly fractured piece of the comet, a phenomenon known as cleavage in minerals. The second path points to a perfect storm of digital noise, a 1 in a billion collision of a random cosmic ray hitting the sensor at a shallow angle, which is then amplified and squared off by the blocky math of video compression. Many favor this, arguing an illusion is always more likely than an alien artifact, but a third idea keeps resurfacing. Some, like a fringe group of material scientists, propose the edge is exactly what it looks like, something manufactured. The specular reflection is more consistent with a polished alloy or ceramic than fractured ice. It remains the least likely but most elegant explanation for the visual data alone. Broader implications. An event like this ripples far beyond astronomy forums. When a NASA feed cuts at the exact instant an anomaly appears, it sends a jolt through public imagination and scientific policy. Dr. James Evans, a sociologist at the University of Chicago who directs the Knowledge Lab, might write that the event forces a confrontation with a profound possibility in a tangible way that SETI's radio silence has not. It moves the search for extraterrestrial intelligence from a passive listening exercise to an active forensic one. Funding priorities can shift. Lawmakers might propose a Data Transparency in Astronomy Act, mandating real-time decentralized public mirrors for all major observatories. For everyone watching at home, it becomes a test of media literacy. Is this a glitch, a cover-up, or a genuine hint of something bigger? If one frame can change how we search the skies, what happens when the next visitor breaks all the rules? It pushes the line between healthy skepticism and profound wonder just a little bit further. impacting public trust in scientific institutions. The search continues. As of today, the glint in that final frame from 3I Atlas remains an officially unexplained phenomenon. There is no conclusive evidence to support either a natural or an engineered origin. The technical explanation is plausible, but the timing keeps the question alive. What is clear is that every new visitor from beyond our solar system pushes our technology and our protocols forward. Dr. Paul A. Abel of the NASA Johnson Space Center, who has worked on concepts for rapid response missions, might say the mystery has already fueled calls for automated systems. These systems would use AI to analyze survey data in real time and upon detecting an anomaly like unusual light curves or trajectories, could automatically trigger follow-up observations from other telescopes around the world within minutes. This is a direct lesson from being caught off guard by 3I Atlas. The search for answers continues, not just in old data archives, but in the sky itself, as we wait for the next messenger from the void to make its presence known. The story of 3I Atlas is a perfect storm of data, doubt, and tantalizing possibility. A verified, untampered frame shows something that defies easy explanation, followed by a blackout at the most suspicious moment imaginable. Is it a ghost in the machine, a cosmic coincidence, or the first faint signature of technology from another star? The debate rages on, fueled by that single silent image. Whatever the answer, it reminds us that we are still just beginning to explore the vast, unknown ocean of space. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the cosmos. Thank you for watching Space Facts. So, what if the most terrifying message from the stars wasn't actually a broadcast, but an object? And what if that object wasn't just, passing through, but actually reporting back to something else out there? In 2025, officials confirmed the detection of our solar system's third interstellar visitor, an object they called 3I Atlas. But as they decoded its transmissions and analyzed its totally impossible flight path, they confirmed a fear that humanity has honestly held for centuries. This wasn't just some random rock, it was a messenger. So, let's explore this together. The impossible visitor. So what happens when a visitor from another star system doesn't just tumble through, but actually navigates? When the Vera C. Rubin Observatory in Chile first flagged 3I Atlas in early 2025, it immediately defied every known classification. Unlike our previous interstellar guests, this object showed something that, sent a chill through every Mission Control Center controlled flight patterns. Dr. Karen Meach, a University of Hawaii astronomer famous for her work on Oumuamua, was among the first to point out that its trajectory was, quote, non-ballistic to a degree that is simply not natural. It executed deliberate, impossibly precise course corrections. Its sheer scale was staggering. It was surrounded by this massive 700,000-kilometer coma, a glowing envelope of gas and plasma nearly half the diameter of our own sun. But unlike a comet's coma, this one didn't sublimate chaotically. It pulsed, beating like a cosmic heart with powerful electromagnetic signals at a frequency of 1.42 gigahertz. The hydrogen line, which is pretty famous in SETI circles, firing in a perfect rhythm, once every 147 seconds. As this impossible visitor carved its way through our asteroid belt with surgical precision, one chilling question began to emerge. What if this thing wasn't exploring, but was actively reporting back? When physics stopped making sense. Here's where the story honestly takes a sharp turn from scientific curiosity into a genuine threat. Most objects from beyond our solar system follow these chaotic trajectories, their paths just dictated by gravity. But 3I Atlas showed us something entirely different. Its path allowed it to drift past several planets in ways that maximized gravitational efficiency, a maneuver that reminded JPL engineers of those complex gravity assist routes they designed for probes like Voyager. When celestial mechanics experts like Jacques Lasker from the Paris Observatory ran the orbital simulations backward, they found something, statistically impossible without intelligent intervention. The path of 3I Atlas required navigating through dense meteoroid streams and planetary collision zones with a mathematical elegance that was honestly breathtaking. Its trajectory deviated from a purely gravitational path by a measured 0.05 arc-seconds per hour, a tiny but constant thrust that had no visible source. It moved like a grandmaster's chess piece on a cosmic board. avoiding every conceivable threat with a precision that suggested either advanced, long-term planning, or some kind of sophisticated real-time control. This wasn't just a random space rock wandering through the cosmos. It was, as some scientists began to describe it, exhibiting piloted behavior. The object that defied reality. The unsettling feeling that we were dealing with something far beyond our comprehension only got stronger when NASA, under the guidance of senior JWST scientists like Dr. Jane Rigby, pointed the James Webb Space Telescope toward 3I Atlas. The results that came back didn't just challenge our understanding, they totally rewrote the rulebook. The thermal readings showed a consistent, stable temperature of 120 Kelvin, with rhythmic heat emission patterns that pulsed in sync with its radio signals, a behavior that, honestly, just defies thermodynamics. Webb spectrography revealed materials never before seen, including hyper-reflective compounds that returned almost 99% of the light that hit them. But the most disturbing discovery was a faint, recurring electromagnetic anomaly echoing from within. This low-bandwidth frequency at 408 MHz repeated every 147 seconds, matching the exact signature of a known pulsar, PSRB 1919+21. The problem, as any physicist would tell you, was that the object had no spinning core and no magnetic field capable of generating such a signal. It looked like it was mimicking something it had encountered, or even worse, actively communicating with something beyond our detection capabilities. 2 visitors, 1 terrifying pattern. The mystery deepened significantly when researchers cross-referenced the electromagnetic signature of 3Y Atlas with archived data from Oumuamua. The comparison revealed something that honestly sent shockwaves through the scientific community. The exact same 147-second frequency had been detected briefly in Oumuamua's data, a faint 3 sigma detection that was initially dismissed as noise. The crucial difference, though, was that 3I Atlas's signal was a powerful, sustained 50 sigma detection, an unmistakable beacon. This discovery, championed by controversial Harvard astronomer Avi Loeb, completely reframed our understanding of both objects. Oumuamua had puzzled scientists, but now a disturbing pattern emerged. The evidence suggested that Oumuamua may have been a reconnaissance probe. If this theory held merit, then 3I Atlas represented something far more significant, not passive observation but active engagement. It was, in effect, the difference between a single radar ping and a fully operational surveillance system. Some researchers now theorize that Oumuamua was the lock, and 3I Atlas is the key, designed not just to observe but to unlock something, whether buried on our planet or awaiting activation in orbit. When space objects make calculated decisions. Just when scientists believed they had mapped 3I Atlas's future trajectory, the object performed a maneuver that, honestly, shattered every remaining assumption. Telescopes in Chile and Hawaii recorded a subtle but unmistakable course shift that couldn't be explained by gravity or solar wind. The object veered slightly off its projected arc, executing a 15-meter-per-second delta V that realigned its vector, bringing it 1/10 of an astronomical unit closer to Earth's orbital plane. To mission analysts at NASA's Deep Space Network at JPL, the implications were, well, alarming. The timing and precision of this maneuver implied conscious decision-making. Even more intriguingly, the maneuver occurred precisely when the James Webb Space Telescope had achieved its optimal tracking position, suggesting the object was not only aware of our surveillance efforts, but was reacting to them. This transformed 3Y Atlas from an astronomical curiosity into a potential confirmation of technologies far beyond our own. It was no longer a passive object of study, it was an active participant in a cosmic dialogue we didn't know we were having, a dialogue that was now escalating. Ancient mathematics from the stars. As if its movements weren't enough, independent cryptographers at the SETI Institute, inspired by the lifelong work of pioneers like Dr. Jill Tarter, uncovered something extraordinary. Using Fourier analysis of the pulse's phase modulation, they found precise mathematical ratios hidden within the signal, the golden ratio, Fibonacci sequences, and the first 100 prime numbers encoded in binary. These weren't just arbitrary concepts, they represent fundamental codes that appear throughout the natural universe. The precision of these patterns suggested a level of mathematical sophistication far beyond random cosmic noise. Even more disturbing, though, was the dynamic nature of these signals. The mathematical patterns weren't constant, they changed subtly, reacting to solar activity and even our own radio emissions. Most chilling of all, researchers detected a brief disruption, a single skipped pulse, that matched exactly with the moment James Webb first locked onto it. The object appeared to know it was being observed, and had responded with a mathematical fingerprint that spoke a language older than human civilization itself. Organic chemistry from beyond the stars. So, James Webb's detailed spectroscopic analysis revealed another, disturbing layer to the 3I Atlas mystery. The telescope detected complex carbon molecules on the object's outer shell, specifically polycyclic aromatic hydrocarbons, which are, the building blocks of prebiotic chemistry. These compounds, as astrobiologists like Carl Sagan have long theorized, are the precursors to life itself. But what was really alarming was the purity and organization of these molecules. Unlike the chaotic mixtures found in comets, the compounds on 3Y Atlas showed 99.9% isotopic consistency, a level of molecular organization that just doesn't occur naturally in space. The spectral lines at 3.3 micrometers, a key signature of PAHs, were unnaturally sharp and clear. Some researchers, including those at MIT under the guidance of experts like Dr. Sarah Seeger, began to theorize that 3Y Atlas might represent a seed ship, an ancient vessel designed not just to explore but to plant the foundations of life on suitable worlds. If this theory held merit, then Earth's location along the object's trajectory might not be a coincidence at all. When Earth responded to the cosmic visitor. When Earth responded to the cosmic visitor, the connection between 3.1 Atlas and Earth became, well, far more unsettling. A classified high-altitude surveillance balloon, managed by the U.S. Antarctic program, detected something extraordinary. The balloon's instruments recorded a powerful microwave burst at 23.5 gigahertz, sharp and centered precisely above the South Pole. Now, at first this was dismissed as interference, but its timing aligned perfectly with another angular shift in 3Y Atlas's trajectory. Moments after the burst, seismic stations that are part of the global seismographic network recorded ultra-low frequency rumbles across the frozen continent. These deep, resonant frequencies were a perfect 0.0068 Hz, the exact inverse of the 147-second pulses being emitted by 3.1 Atlas. The synchronization was just impossible to dismiss as a coincidence. Somehow this visitor appeared to be influencing activity on our own planet, possibly triggering responses from systems buried deep beneath the Antarctic ice. The object wasn't just passing by, it was actively interacting with Earth in ways that suggested a technological sophistication far beyond our current understanding. The Asteroid Belt Death Run. 3. I-Atlas is currently navigating through the main asteroid belt, a phase that presents honestly unprecedented risks. Unlike other objects, 3I Atlas cuts directly through the belt's core at a low 5-degree inclination, passing through a region with a particle density 50% higher than the belt's average. The object, moving at a blistering 42 kilometers per second, is surrounded by its massive 700,000-kilometer coma, creating unprecedented interactions with the billions of objects in the belt. Planetary scientists at institutions like the Southwest Research Institute are watching with bated breath. As 3Y Atlas moves through this environment with its powerful electromagnetic signature, it's creating disturbances never before observed. While a direct collision remains statistically low, its gravitational and electromagnetic effects could potentially alter the trajectories of other bodies in unpredictable ways, creating a cascading effect or, more concerningly, redirecting the object itself toward Earth's orbital path. This is a cosmic gamble with planetary consequences. Rewiring our solar system's neural network. Scientists have now discovered that 3Y Atlas's interaction extends far beyond simple gravitational effects. Its complex, dusty plasma envelope is actively interacting with the solar system's magnetic field, creating what researchers are calling an electromagnetic web effect. As 3Y Atlas cuts through the inner solar system, it could be generating packets of charged dust that flow along the sun's natural electric currents toward Earth, potentially triggering geomagnetic storms. But the most disturbing discovery is the most recent. Observations from the Allen Telescope Array show that 3Y Atlas has begun emitting a secondary signal, a lower frequency, longer pulse at 700 MHz, pointed directly toward the Orion constellation. As SETI astronomer Seth Shostak noted, a signal not pointed at us is infinitely more chilling. Some researchers believe it's calling for reinforcements. Others think it's reporting back on its findings, but either way, one conclusion seems undeniable. This was never just an interstellar rock. This was a node, a probe, a messenger, broadcasting to something else that is still on its way. The story of 3I Atlas is far from over. In fact, it may just be the beginning of a much larger, more terrifying story. The mounting evidence, the deliberate course corrections, the mathematical signals, the organic chemistry, and now a broadcast pointed toward deep space, all suggest that this object is not the main event. It is a precursor. It is an announcement that our solar system is no longer a quiet, isolated neighborhood. We may have just accidentally triggered a sequence of events that will fundamentally change humanity's place in the universe, and honestly, we are completely unprepared for what comes next. Thank you for watching Space Facts. An object from beyond our sun barreled through the inner solar system on October 19, 2017, moving so fast it couldn't possibly have come from here. Astronomers named it Oumuamua, messenger from afar, and soon realized its brightness was flipping tenfold every 8 hours, hinting at a shape unlike any natural body we've ever seen. Oumuamua initial detection. A cosmic intruder just crashed our solar system's private party, and it came from another star. On October 19, 2017, astronomer Robert Warwick was scanning telescope data at the University of Hawaii when he spotted something that shouldn't exist, a fast-moving object that didn't belong to our neighborhood. The Pan-STARRS 1 telescope had captured humanity's first glimpse of an interstellar visitor, something that had traveled for millions of years through the void between stars just to reach us. What made this discovery so extraordinary wasn't just the object itself but the incredible timing. Scientists estimate that only one interstellar object passes through our solar system every few years, and most are just too small or too fast to detect. Scientists quickly realized this wasn't space junk or a rogue asteroid from our own system. The trajectory was all wrong, the speed was incredible, and the direction it came from pointed to deep space. They named it Oumuamua, a Hawaiian word meaning scout or messenger from afar, because it truly was our first confirmed messenger from another star system. The discovery process itself was remarkable. Warwick initially thought it might be an error in the data until he tracked the object across multiple images. Within days of discovery, telescopes around the world were frantically tracking this mysterious visitor as it raced through our solar system at 26 kilometers per second. The Minor Planet Center in Cambridge immediately issued alerts to observatories worldwide, triggering an unprecedented international collaboration. The object was already past its closest approach to the sun and heading back into interstellar space, giving scientists only a brief window to study it before it disappeared forever into the cosmic dark. What they found would challenge everything we thought we knew about space rocks, comets, and the possibility that we might not be alone in the universe. This cosmic messenger was about to rewrite the textbooks and spark debates that continue today. Classification challenges. Scientists love putting things in neat categories, but Oumuamua refused to play by the rules and turned astronomical classification into chaos. Initially classified as Comet C/2017 U1 on October 25, 2017, researchers expected to see the classic signs: a glowing tail, a fuzzy coma of gas and dust as ice sublimated near the sun. Comets are essentially dirty snowballs that light up beautifully as they approach our star, creating spectacular displays that have inspired humans for millennia. But Oumuamua was having none of it. No tail, no coma, no visible outgassing whatsoever, even though it had passed closer to the sun than Mercury's orbit. This was like expecting a snowball to melt in a furnace and finding it completely unchanged. Confused astronomers quickly reclassified it as Asteroid A/2017 U1, but that didn't feel right either. Traditional asteroids are rocky or metallic chunks left over from planetary formation, and they follow predictable patterns based on billions of years of observation. But Oumuamua's behavior was inconsistent with known asteroid properties. Its rotation rate, brightness variations, and movement patterns all suggested something fundamentally different. By November 2017, the International Astronomical Union faced an unprecedented problem and created an entirely new classification system just for Oumuamua, designating it 1I/2017 U1, the I standing for interstellar. This was the first time in astronomical history that a completely new category had to be invented for a single object, highlighting just how unprepared science was for visitors from other star systems. The classification headache revealed something profound. Our understanding of cosmic objects was based entirely on things that originated in our solar system, shaped by our sun's gravity and radiation over 4.6 billion years. Oumuamua was playing by different rules written in another star system billions of years ago under completely different conditions. Its refusal to fit into existing categories was the first hint that this visitor was unlike anything we'd ever encountered. And scientists began to realize they weren't just looking at a space rock, they were examining an alien artifact from deep space. Trajectory analysis. Tracking Oumuamua's path through space was like following breadcrumbs back to another world, and the story it told was absolutely mind-blowing. Astronomers used precise measurements from observatories worldwide, including the Very Large Telescope in Chile and the Gemini Observatory in Hawaii, to reconstruct its journey with incredible accuracy. What they found was a cosmic wanderer that had been drifting through interstellar space for millions of years before accidentally stumbling into our solar system like a lost traveler finding civilization. Dr. Marco Micheli and his team at the European Space Agency traced its origin to the general direction of the constellation Lyra, specifically toward the star Vega, one of the brightest stars in our night sky. But here's the incredible part. Even if it came directly from Vega, it would have taken 600,000 years to make the journey, meaning this object began its voyage when early humans were just learning to control fire. The trajectory analysis revealed that Oumuamua wasn't bound to any particular star system. It was a true galactic wanderer that had been drifting through the local standard of rest, the average motion of stars in our galactic neighborhood. The object entered our solar system from above the plane where planets orbit, approaching at a steep 122-degree angle that no local object could achieve. This approach angle was like a cosmic signature proving its interstellar origin beyond any doubt. Its hyperbolic trajectory meant it was moving too fast to be captured by the sun's gravity. This was a true flyby mission with no possibility of return. The orbital calculations revealed Oumuamua came within 0.25 astronomical units of the Sun on September 9, 2017, closer than Mercury's orbit, experiencing temperatures of over 300 degrees Celsius before being flung back toward interstellar space by gravitational slingshot effects. By the time astronomers discovered it in October, it was already racing away at 44 kilometers per second relative to the Sun, fast enough to travel from Earth to the Moon in just over 2 hours. The trajectory analysis proved beyond doubt that this was our first confirmed visitor from another star system, a cosmic time capsule that had witnessed the birth and death of distant worlds, survived the radiation of interstellar space, and arrived at our doorstep carrying secrets from the galaxy beyond. Photometry and shape analysis. So, photometry and shape analysis showed that Oumuamua was doing something no space rock should do. It was flashing like a cosmic lighthouse. Photometric observations from multiple telescopes revealed that the object's brightness varied by an extraordinary factor of 10 every 7.3 hours as it tumbled through space. This dramatic brightness change suggested something unprecedented, an object so elongated that it was unlike anything in our solar system. Dr. Karen Meach from the University of Hawaii led the analysis, calculating that Oumuamua was at least 10 times longer than it was wide. Imagine a cosmic cigar, or maybe a football spinning end over end. Some models even suggested it could be more extreme, possibly a 20-to-1 length-to-width ratio. But Dr. Sergei Mushchenko proposed an alternative. What if it wasn't cigar-shaped but pancake-shaped? A flat, disc-like object could also produce the same brightness variations. The tumbling period was unusual too. Most asteroids rotate much faster, but Oumuamua's leisurely spin suggested it might be held together by something other than typical rocky materials. The photometric data painted a picture of an object so bizarre that it challenged our understanding of how planetary formation works. No known process in our solar system creates objects with such extreme dimensions. This wasn't just unusual, it was honestly geometrically impossible, according to everything we knew about how gravity shapes space rocks. Oumuamua was, in a sense, rewriting the rules of cosmic architecture. Acceleration anomaly. And then, there was the acceleration anomaly. Oumuamua just broke physics, and scientists are still trying to figure out how. As telescopes tracked the object's movement away from the sun, something impossible happened. It started accelerating faster than gravity alone could explain. Dr. Marco Michelli's team at ESA first detected this non-gravitational acceleration in June 2018, analyzing data from the Hubble Space Telescope and ground-based observatories. The acceleration was tiny, only about 0.00005 meters per second squared, but it was real and measurable. For comparison, if you dropped a feather and it fell upward instead of down, that would be less surprising than what Oumuamua was doing. In our solar system, when objects accelerate away from the sun without gravitational explanation, it's usually because they're comets releasing gas and dust that creates a rocket-like thrust. But Oumuamua showed no signs of such outgassing. No tail, no coma, nothing visible that could explain the extra push. The acceleration was also pointing in exactly the right direction, directly away from the sun, which made it even more mysterious. Professional astronomers ran the calculations dozens of times, checked their instruments, and consulted with colleagues worldwide. The result was always the same. Oumuamua was being pushed by an invisible force. This single observation transformed a curious interstellar visitor into one of the most puzzling objects ever detected, launching 1,000 scientific theories and capturing the imagination of anyone who wondered if we might not be alone. Spitzer observations. NASA brought out the big guns to solve the Oumuamua mystery, and what they found made everything more confusing. The Spitzer Space Telescope, with its incredibly sensitive infrared detectors, was humanity's best hope for detecting any invisible outgassing that might explain the object's mysterious acceleration. Dr. David Trilling from Northern Arizona University led the observations in November 2017, pointing Spitzer's instruments at Oumuamua as it raced away from the inner solar system. Infrared telescopes can detect heat signatures from sublimating ice and microscopic dust particles that are completely invisible to optical telescopes. If Oumuamua was secretly behaving like a comet, Spitzer would catch it red-handed. The results were published in the Astronomical Journal in 2018, and they were as puzzling as they were definitive. Nothing. Absolutely nothing. Spitzer's upper limits on dust and gas production were so strict that they ruled out traditional cometary activity by orders of magnitude. If Oumuamua was releasing material to create thrust, it was doing so at levels 10,000 times lower than typical comets. This wasn't just unusual, it was physically implausible. The Spitzer observations eliminated the most obvious explanation for the acceleration anomaly and forced scientists to consider more exotic possibilities. Either Oumuamua was made of materials that don't exist in our solar system, or it was being pushed by forces that we don't understand, or, well, it wasn't natural at all. Artificial origin hypothesis. So here's the thing. Harvard astronomer Dr. Avi Loeb dropped a scientific bombshell that made headlines worldwide and honestly divided the astronomy community. Back in October 2018, Loeb and his postdoc Dr. Shmuel Bialy published a paper suggesting that Oumuamua might not be a natural object at all. It could actually be artificial technology created by an alien civilization. Their hypothesis, which was published in the Astrophysical Journal Letters, proposed that Oumuamua was a light sail, an ultra-thin sheet of material designed to be pushed by radiation pressure from stars. This idea would explain both its unusual shape and the mysterious acceleration, without needing any detectable outgassing. And, light sails are real technology that humans are developing for interstellar missions, so the physics behind it was actually sound. Loeb calculated that an object only millimeters thick, but hundreds of meters wide could behave exactly like Oumuamua, accelerating away from the sun as starlight pushed against its surface. The paper, as you might imagine, sparked fierce debate in the scientific community. Critics argued that invoking alien technology violated Occam's razor, the principle that simpler explanations are usually correct. But Loeb countered that the scientific method requires considering all possibilities, even the uncomfortable ones. His 2021 book, Extraterrestrial, further developed this hypothesis, arguing that scientists' reluctance to consider artificial origins was more about sociology than science. Whether he's right or wrong, Loeb's proposal really forced astronomers to think outside conventional boundaries, and consider that our first interstellar visitor might have been our first contact with alien engineering. Dark comet theory. So scientists found a kind of middle ground between the idea of a normal space rock and the more far-out theory of an alien spacecraft, and it's called the dark comet hypothesis. Dr. Darrell Seligman from the University of Chicago, along with his colleagues, actually proposed back in 2019 that Oumuamua belonged to a previously unknown class of objects that behave a lot like comets but basically remain invisible to us. These so-called dark comets would have just enough ice to create the non-gravitational acceleration we saw, through a process called sublimation, but at levels so low that our instruments just couldn't pick up the outgassing. The theory suggested that Oumuamua was made of materials that had been altered by billions of years of exposure to cosmic radiation out there in interstellar space. This kind of space weathering could create a dark, carbon-rich crust that would hide any ice underneath and make the object look a lot more like an asteroid than a comet. Computer simulations even showed that tiny amounts of sublimating hydrogen gas, basically invisible to most telescopes, could produce exactly the kind of acceleration that was observed. The dark comet model explained Oumuamua's behavior without needing to invoke exotic physics, or, alien intervention. It also suggested that interstellar space might actually be filled with these mysterious objects, failed comets, planetary fragments, or debris from destroyed worlds that have been wandering between the stars for eons. The hypothesis gained even more credibility when astronomers began finding similar objects right here in our own solar system. Small bodies with mysterious accelerations but no visible outgassing. So, Oumuamua might not be unique after all. Maybe it's just the first representative of a hidden population of dark wanderers that populate the galaxy. Dark comet classification. The mystery of Oumuamua got even more interesting when astronomers started spotting similar objects basically hiding in plain sight within our own solar system. In 2023, Dr. Darrell Seligman and his team published some pretty groundbreaking research identifying 7 near-Earth objects that showed the same puzzling behavior: non-gravitational acceleration without any visible outgassing. These objects, now officially classified as dark comets, provided the missing link in understanding Oumuamua's true nature. The research published in the journal Icarus actually revealed 2 distinct populations of dark comets in our solar system. Outer dark comets like 2003 RM and 2010 BK118 follow eccentric orbits similar to traditional comets but show no visible activity. Inner dark comets, like 2007 VA85, orbit closer to the Sun and tend to be smaller, which suggests different formation mechanisms or evolutionary histories. This discovery was honestly revolutionary because it meant dark comets weren't just rare interstellar oddities. They were a previously unrecognized population that had been masquerading as asteroids for decades. The new classification system distinguished them from regular comets and asteroids based on their orbital dynamics and the lack of any detectable coma or tail, despite clear evidence of non-gravitational forces at work. Finding dark comets in our own solar system strongly supported the idea that Oumuamua belonged to this category. It suggested that these kinds of objects might actually be common throughout the galaxy. Invisible wanderers moving between star systems, maybe even carrying ice and organic materials that could seed life on distant worlds. The dark comet classification really transformed Oumuamua from a unique anomaly into the first confirmed member of a whole cosmic population we never even knew existed. Scientific debate. 5 years after Oumuamua's flyby, the scientific community is still, fascinatingly divided. And that's actually how science should work. Multiple competing theories keep battling it out in peer-reviewed journals, with each one having some pretty compelling evidence and passionate supporters. The mainstream scientific consensus has gradually shifted toward the dark comet explanation, with researchers like Dr. Jennifer Bergner from the University of California, Berkeley publishing detailed models in 2023, showing how hydrogen outgassing could explain every observed characteristic of Oumuamua. Meanwhile, Dr. Avi Loeb continues to push for the artificial origin hypothesis, launching the Galileo project to search for similar objects and develop new detection methods for potential techno-signatures. Some conservative astronomers prefer explanations involving exotic but natural processes. Maybe Oumuamua was a fragment of a nitrogen iceberg from a Pluto-like world, as Dr. Alan Fitzsimmons proposed back in 2021. The debate has actually produced over 200 scientific papers since 2017, each one adding new pieces to the puzzle. What makes this controversy especially valuable is that it's driving innovation in observational astronomy and interstellar object detection. Projects like the Vera Rubin Observatory, which is set to begin operations in 2024, will discover hundreds of interstellar visitors in the coming decade. The European Space Agency's proposed Comet Interceptor mission could even rendezvous with the next Oumuamua-like object. No matter which theory ends up being correct, Oumuamua has fundamentally changed our perspective on the solar system's place in the galaxy, and reminded us that the universe still holds some pretty profound mysteries waiting to be solved. Alright, that's a wrap on Oumuamua's mind-bending mystery. This interstellar visitor really challenged everything we thought we knew about space objects and honestly left us with more questions than answers. Was it a dark comet, alien technology, or something else entirely? The truth is still out there, just waiting to be discovered. So, what do you think Oumuamua really was? Drop your theories in the comments below. I actually read every single one. And hey, if you're hungry for more cosmic mysteries and space facts that'll totally blow your mind, make sure to hit that subscribe button and ring the bell icon so you never miss our latest discoveries. The universe is full of secrets, and we're just getting started uncovering them together here at Space Facts.